Back everybody. So what we have done, so we have covered the EIGRP protocol, and so basically we have seen that EIGRP is a advanced distance vector routing protocol, but still a distance vector routing protocol, right? And in our advanced distance vector routing protocol, what happened? Majorly the problem with the distance vector routing protocol, the main issue is that they don't have a complete knowledge about the topology. For example, the major issue why we are not using the EIGRP in the service point. See, it doesn't mean that we are not using the EIGRP. We are still using the EIGRP in the production network, like an enterprise network. But if I talk about the service provider perspective, right, why we are not using it, the reason is that if you see router 1, I have, router 2 we have, right, and router 3 we have. So the problem with the EIGRP protocol is what? Router 1 only has a knowledge of the router number 2. So router 1 has a complete knowledge about the router number 2. Router 3 has a complete knowledge about the router number 2. Router 1 doesn't have a complete knowledge about the router 3. That's a problem in the EIGRP. In a EIGRP routing protocol, or we can say that in a distance vector routing protocol, they only know about the neighbors. They only have a detailed information about the neighbor. That's all. They don't have other, R1 doesn't have a knowledge of the R3. So it's same like on the highway, if you see that there's a pamphlet, boards are there, the sign boards are there. If you go straight, then you will reach to the that destination, X destination. If you go right, then you will reach to the Y destination. Same way, if you reach to the router number 2, then you will get to know that about the router number 3. But from here itself, you will never get to know about the router 3. Okay, you will have a route. Okay, you will have a route of the 3.0.0 in the R1 routing table, but the detailed information you will not have. You will not have an idea how does this route is connected, right? This is the major issue why we are not using the distance vector routing protocol in the service provider network, and that's why we came with a solution is called the link state routing protocol. In the link state routing protocol is what happened, right? R1, right? If there is a router 1 has a knowledge about the router number 2. At the same time, router 1 has a knowledge about the router number 3. It means that if you're sitting on the router number 1, you can see that how this network is connected. How this network is connected. What is the subnet mask information? What is the loopback? Is it a loopback interface, or is it a fast Ethernet interface, transit network? So you can see from here itself on the router number 1, but you cannot check in the EIGRP protocol. In the EIGRP protocol, what happened? You can see that, okay, D 3.0.0 network we have. You will not have an idea how this network is connected behind the router number 3. Like, is it a loopback interface or is it a transit network? That's you can see in the case of OSPF protocol. I'll show you that. So that's why we came with the solution is called link state routing protocol. In the link state routing protocol, we have two solutions. One, we have a OSPF, one we have a ISS protocol. So majorly, if I talk about, OSPF is a pure layer 3 protocol, and it's only work on the IP protocol. So if I talk about the EIGRP protocol, EIGRP works on the IP, then it works on the IPX protocol as well, Apple talk. So these are the protocol in the older time. So, right, of course, IP is a dominant nowadays. That's why you only heard about the IP. But in the 90s time, we have another protocol that's the IPX. For the Apple communication, we have an Apple talk. So EIGRP does support for the all those three protocol. But OSPF is a pure IP-based protocol, right? It's a layer 3 protocol. It works on the network layer, right? And the protocol number of the OSPF is what? 89, whereas the EIGRP has a 88. Same way, another type of link state routing protocol we have is called the ISS protocol. ISS is a pure layer 2 protocol. It's not work on the network layer. It works on the data link layer. That's a beauty, right? Because of this reason, right, we are running the ISS protocol in the in ISP's network service point. The reason is that majorly the attack is happening on the IP side, not the MAC side. So person has a knowledge of the IP, but they don't have a knowledge of the MAC, right? So majorly because of the security perspective, or of course, there is a scalability perspective. We are using the ISS in the majorly in the service provider network, and also in the small service provider network, we are running the OSPF protocol as well. But you will never ever see the EIGRP as a protocol in the service provider network. If you see the EIGRP in the service provider network, then make sure that you will not have a MPLS traffic engineering. This is the one of the topic we have. This is advanced topic in the service border. So you will, because MPLS traffic engineering doesn't support the EIGRP. And this is the major MPLS traffic engineering or segment routing. These are the major topic, right, in the service border network. So these two topics, right, these are the two features that doesn't support the EIGRP. So if you want to implement these two features, you need to implement the OSPF and ISS protocol. So these are the major reasons why we are going to go with the OSPF and ISS, right? And another thing is that EIGRP works on the routing by rumors. Routing by rumors means what? R1, R2, and R3. So R3 will say this guy, hey, 3.0.0 network is a 10 metric. Whatever the R2 will say to the R1, hey, 3.0.0 is a 50 metric, R1 has to believe it because R1 just have a knowledge about the neighbor only, right? In a EIGRP protocol, what happened? R1 just have a knowledge about the router number 2, that's all. R1 doesn't have a complete knowledge about the router 3. And R1 doesn't have a complete knowledge about the 3.0.0 subnet, right? So they only know about the R2. So whatever the R2 will tell to me, I have to believe it. That's called the rumors. So whatever the R2 will tell, if the R2 will say that, okay, this 3.0.0 is a 100 matrix away, I have to believe it. So that's another problem we have, right, with the EIGRP protocol. So that's why we are moving to the OSPF one. So OSPF is a link state routing protocol, and it's an open and standard protocol. OSPF, it's an open shortest path first. So the first keyword is itself is open, right? Open means what? It's a IEEE standard protocol. So whereas the EIGRP, if you see that, it's a Cisco provided protocol. Initially, it was a Cisco proprietary, right? But nowadays, it's a IEEE standard protocol. So open means what? It can run on the any vendor. So if you have a Juniper, if you have a Cisco, if you have a Huawei, if you have a Palo, Checkpoint, anywhere you can run the OSPF protocol. The meaning of shortest path means what? It always finds the shortest path to reach the destination. So OSPF works on the layer 3 protocol. It has a protocol number will be 89. It has a 2 multicast address, whereas EIGRP has a single one. The reason we have a 2 multicast address because we have a 224.0.0.5 and 224.0.0.6. So we have a 2 multicast address if you compare with the EIGRP. So it means that your interface will join this 2 multicast address, right? Now, what is the use of this 2 multicast address? If you see in case of EIGRP protocol, take example. We have router number 1 and we have a switch over there. And we have a router number 2 and we have router 3 and we have router 4 and we have router 5. So understand this concept. Let me draw the same one. I'll put the IP as well. So this is the IP will be, this IP is a 1.1, this IP is 1.2, this IP is 1.3, this IP is 1.4, this IP is 1.5. I'll make sure that the router ID will be 1.1, this router ID will be 5.5.5.5, router ID 4.4.4, router ID 3.3.3.3. Can anyone tell me how many broadcast domain already we have right now? It's a single broadcast domain, right? So in EIGRP protocol, what happened? Understand this concept. Let me copy and paste it. Hold on, I need to increase the size. Guys, please pay attention. This is a very important one that you will understand the majorly difference EIGRP and OSPF right now. So now let me take a sniff and copy and paste. So take example, this side we are running with the EIGRP protocol, right? So normally in the EIGRP protocol, what happened, right? Router 1 is gonna make a neighbor relationship with router number 2, right? It's also gonna make an adjacency as well, right? Router number 1 also gonna make the neighbor relationship with the router 3 and adjacency as well. Router 1 also gonna make the neighborhood adjacency as well this guy, and also form this guy, right? Same way, it's also gonna form the neighborhood adjacency. It's also gonna form the neighborhood adjacency, and it's also gonna form the neighborhood adjacency between this guy, right? Same way, we are also gonna form the neighborhood adjacency between this guy to this guy, and we are also gonna form the neighborhood adjacency between this guy to this guy. So if you see, it's like a full mesh we have. It means that, understand the concept, and it means that if router 2 has a route 2.0.0.0 network, right? And if router 2 wants to advertise this network, how many update packet he will send? He will send a multi, he can directly send to this guy. He can directly send to this guy as well. He can directly send to this guy, right? So he has the ability, he can update to the anybody. So there is no any centralized management over there. There is no any centralized management over there. Anyone can send the route to the anybody. Anyone can send the route to the anybody over there in the EIGRP protocol. In OSPF normally what happened? In this broadcast network, OSPF will elect the one router as a DR router. OSPF will elect as a one router as a DR router. So take example, this router is my DR. For the DR, if the DR goes down, so what happened? To just make a faster convergence, right? To just make a faster convergence, what happened? OSPF choose the backup router for this DR. I'll say the BDR. That's my backup router. And the remaining router will go with the DRO. So this guy will go with the DRO, this guy will go with the DRO, and this guy will go with the DRO. Now, don't worry, I'll explain you the concept of the DR and BDR. I'm just trying to differentiate the EIGRP and OSPF. So now understand, we have a DR over there, right? In this picture, we have a BDR over there, and remaining all the router will be DRO. You can assume that your DR is like your class monitor, right? A DR is like a class monitor, and BDR is like a backup class monitor. Monitor is like a class representative, we can call it, and this is the backup class representative. So now understand what happened. Every DRO, right? Every DRO is gonna make a neighbor relationship and adjacency with the DR and BDR. Why we are making it with the BDR? If somehow the DR will fail, I will get the faster convergence. The BDR will automatically become the DR. Guys, please pay attention to my words. If the DR will fail, right, to just make a faster convergence, I'll make a backup BDR. So the BDR will become the DR if the DR goes down. Then what happened? Same way, this router is going to make a neighbor relationship with this guy. That's how the neighborship adjacency. Same way, this guy as well, right? Same way, this guy also going to make this guy as with this person and this person as well. So if you have a loop over there, it's not a full mesh over there. It's a full mesh, right? In the case of EIGRP, it's not a full mesh. We can call it a, it's like a point to multi-point scenario, right? It's like a point to multi-point scenario. It's not a full mesh. So now understand how about the DRO and DRO. So if you see that there's no relationship between the router 1 and router 2. So between this guy to this guy, what happened? They only have a neighborship. Between router 1 to router 3, what happened? Again, DRO and DRO. We only have a neighborship. Between this guy to this guy, what happened? We only have a neighborship. Neighborship means what? What do you mean by neighborship? Neighborship means I just know about the router number 3 is there. Adjacency means what? Now I can exchange the route. That's a major difference. So the reason is that, let me write on this thing. The meaning of neighborship means what? Neighborship means I know there is a R2 or there is a R3 or there is a R3, right? Any router ID. Adjacency means what? Now we can exchange the router. Simple language. Now we can exchange the router. So first you are forming the neighborship. Once the neighborship has done, then you are making the adjacency, right? If you check in the EIGRP protocol, in a EIGRP, what happened? Every router is forming the neighborship adjacency. Have a look. Every router, even router 2 to router 3, router 2 to router 1. But in the case of OSPF protocol, in OSPF, what we are doing that? In OSPF protocol, all the DRO router is gonna make a neighborship adjacency with the DR and BDR. Of course, you also have a relationship between this guy and this guy. I forgot to mention that, right? Between the DR and BDR, that's a neighborship adjacency as well. So all the DRO router is gonna make a neighbor relationship and adjacency with the DR and BDR. All the DRO router is gonna make a neighborship adjacency with the DR and BDR. This DR also gonna make the neighborship adjacency with the DR and BDR. But between the DR and DR, if you see, I just have a neighborship. It means that if the router 1 will receive the route, it's a DRO 100.0/8 information. Can I directly exchange the route with the router number 2? No, I can't do that. I need to first send this route to whom? The DR and BDR, right? I will send this route to the DR or BDR as well, right? But of course, the BDR is a backup DR router, so he will not do anything. What DR will now, because DR is the major person, what DR will do now? DR is now going to behave like a centralized management. How? We don't have a centralized management in the case of EIGRP. If you see that, no centralized management. We have a centralized management. Now the DR is going to flood this information to the all person. He's going to flood this information to this guy, this guy, this guy, this guy, this guy. So this router number 2, all the DRO router will receive the information from the DR, and that's the trustworthy, we can say that trustworthy person over there. So he cannot accept the route from the DRO directly. He has to go with the DR, and then DR will flood this information to all the DRO. So DRO directly cannot exchange the route. He has to first send the route to the DR, and that's why we have two types of multicast address. Right, one we have a 224.0.0.0.6 over there. On this particular multicast address is only going to listen by the DR and BDR, not other person can listen it. So DR router cannot join it, this multicast address. And this multicast is 224.0.0.0.5. It will be listened by the all OSPF router. All OSPF router means what? Even the DRO, DR and BDR, all they can join this multicast group. So whenever the router 1, I haven't explained the full form of the DRO yet. You haven't missed anything. So wait for some time. So what happened when the router 1 will receive the, guys, please pay attention to things. When the router 1 will receive the router 1.0.0/8, what he will do that? He will send the update on which multicast address. He will send the update to the DR, and DR is basically listed on which multicast address, .6. So he will send the update packet to the DR, right? Of course, this packet will also receive by the BDR as well, because this part is also listened by the BDR. And then R5 is gonna flip the MAC, and it will change from the 6 to the 5 over there. And then it will send the update to everybody. This is how the things are working in the OSPF protocol, which is not happening in the case of EIGRP. In the case of EIGRP, we have a full mesh scenario. There is no centralized management. There is no any trustworthy person. Anyone can share the update to the anybody. Anyone can share the update to the anybody. It's like a BTP protocol. Remember the BTP protocol we have? All the switches is by default behave like a server. It means that anyone can change the VLAN database. That's not a good thing. That's what we did over there. We make the one guy as a server and remaining all guy as a client. So the client cannot change the database. Only the server can change the database. Same thing in OSPF, we are doing that. In EIGRP, it's like a server. Anyone can change the database. But in this case, what happened? Only the DR is a responsible person who can save the update. If somehow the DR goes down, right, then backup DR comes in the picture. The backup DR will become the DR over there. And just a matter of second, man, in the just a matter of second, what happened? The BDR comes in the picture. So we have just because of the faster convergence, we introduced the backup DR. So this is the another major difference between the OSPF and EIGRP routing protocol. So the first issue, difference we have seen that OSPF, EIGRP is a distance back routing protocol, right? In the distance back routing protocol, what happened? Router 1 only knows about the router number 2. That's all. Router 1 doesn't have an idea of the router 3. Even the router 1 does not know how does this loopback 3.0, how does this 3.0.0 is connected to the router number 3? Is it connected by the loopback, or is it connected by the transit network? Right. So that's a major problem in the case of EIGRP. In EIGRP, it works on the routing by rumors. Whatever my neighbor will tell me, I have to believe it. So they don't in a EIGRP protocol, what happened? You will not have a complete topology information. You just have a neighbor information. A detailed information, you just have a neighbor, what my neighbor is doing that. And there is no centralized management over there, right? Anyone can say the update to the anybody, a full mesh topology like that. But in the case of OSPF, we have a concept of the DR and BDR over there, right? But if I talk about the convergence perspective, EIGRP is amazing. Amazing protocol. In a EIGRP, if you remember that we have a 5 second is the hello time, right? And the 15 second is a hold on time, right? In case of OSPF, we have a 10 second is a hello time and 40 second is my dead interval. Or we can say the hold on time. So, but again, it doesn't mean that this timer is not so important. The major fact is that we have a convergence over there because the reason is that EHRP has a topology table. And in the topology table, if you guys remember that we have a concept of the feasible successor. So by default, feasible successor is present if you have a backup path. But in the case of OSPF, we don't have a kind of topology table, right? So the convergence, if I talk about convergence perspective, EHRP is amazing. But don't worry about that. OSPF has a mechanism to make a faster convergence, right? So now how the OSPF is going to work. Another thing is that in a EIGRP protocol, what happened? We are extending the routes, right? And we can call as a network. So between the router 1 and router 2, we are basically extending the route, right? R1 can say that, hey, there's a 1.0.0, and R2 can say that there is a 2.0.0. But in the case of OSPF, we don't exchange the route. So take example, we have a EIGRP protocol, and EIGRP has a 1.0.0/8 information. So R1 can share this information to the router number 2, 1.0.0/8 via the EIGRP update packet. But in the case of OSPF, right? In the case of OSPF protocol, we don't exchange the route. We are extending the LSA. I'm coming to the point, everything, don't worry about that. So let's start the things. Okay, how the things are going to work. So take examples, my router number 1. And this is my router number 2. Right? And between this guy, I have a link over there. I'm coming to the point of the DR and BDR. Don't worry about that. I'll just give you the difference of that one. That's why. 12.0/24 and 12.2 over there. Remember one thing, OSPF works on IP protocol only. It is a layer 3 protocol. OSPF protocol number is 89. We have 2 types of multicast address. 224.0.0.06. That's going to represent that DR and BDR only. And 224.0.0.05. That's going to represent that all OSPF router. Everyone can listen it, right? OSPF is a linked state routing protocol, right? In this protocol, we don't exchange the route. We exchange LSA. Now understand the concept. Okay, whatever the things you can see right now, you will understand each and every words. Okay, wait for some time. By end of the class, everything you will understand. So right now, what we call this guy, we call as a 0/0. We call as a 0/0, right? We just call as a 0/0 as an interface. So right now, this is called as an interface, right? This is called as a what? Interface. Right? Spec. Now what happened? If I'm going to configure the OSPF protocol, what I told you that the first meaning over there, OSPF works on the only IP protocol, whereas EIGRP works on the IP IPX, and AppleTalk, right? So in the case of EIGRP, if you see that, I'll just gonna open my GNS3. Done. Take it two routers right now. That's enough one. And router 1 and router 2. So I'll explain the meaning of first line over there. I OSPF works on the IP protocol. So let me start this guy. All done. And we have a router 1. So have a look. I don't have any IP address over there, right? If you see, do so IP interface, I don't have anything, right? If I'm going to configure the router EIGRP, I can able to configure it. Okay. There's no any error. There's no any error, right? If you put the do show IP protocol, what he will tell you, hey, you know one thing, I tried to find the router ID, but I could not find it. So what I can do that, I will allocate the router ID as a 0 or 0 or 0 or 0. Perfect. It means that EIGRP is running on there. But if you put the command out OSPF 1, it will throw the error message. Hey, you know one thing, the reason is that we don't have a router ID and cannot be a start. So I need to define any IP over there, right? I really need to define any IPs in the OSPF protocol. Otherwise, it's not going to work. So OSPF works on the IP protocol. You need to have at least one IP on the particular interface. Otherwise, OSPF will not start. Either you can define the router ID manually over there, then it's going to work, or either you can put the IP address over there. So once I'm going to put the command router OSPF, try to understand over there. I said the router OSPF 1. This one is a process ID, guys. Okay. This one is a process ID. Same like that in a EIGRP, we have seen that autonomous system number. It's a process ID. Process ID is a locally significant number. Locally significant number means what? If you're going to configure the process ID router number 1, if you're going to configure the router number 2, no issue. Fine. They can form the neighborship. They can form the neighborship. But in the case of EIGRP, if you remember that, they could not form the neighborship, right? If I'm going to say the EIGRP number 1 and EIGRP number 2, they will not form the neighborship. But in the case of OSPF, they will form the neighborship. The reason is that it's a locally significant. It is a 16-bit of number. You can define from 1 to 65535. Any number you can choose it. But don't do that this way. Always do the same process ID number. If you do the different process ID number, then you will see the issues, right? When you come to the CCI, also the issues comes there. And even if you go with the more higher level, the SP level, the design level, when you understand the design level things, then there's a lots of problems comes over there, right? Route exchange will be problem comes over there. So always make sure that the process ID should be same. Now what? Once after defining the process ID, after that what I can define the manual route ID. The command is very simple. Instead of putting the EIGRP route ID over there like this way, what I can do that in OSPF, we don't need to put the protocol name over there. I just put the route ID. That's fine. Same concept. If you don't put the route ID, right? The first it will take the manual preference. First, it will take the manual preference. Second, it will take the highest loopback interface IP address. And third, it will take the highest physical interface IP address. So if you don't have a loopback, then it will go with the highest physical interface IP address. And if you don't have a highest physical interface IP address, then OSPF will not start. Then what? I need to put the network command. Same useful. The network command is used to enable the interface into the particular routing protocol. Right? It will join the multicast group, advertise the route. So I say the 10.1.12.0. Then you need to put the wildcard mask. For this guy, what will be the wildcard mask? 0.0.0.0 255. Now, the major part, the OSPF. If I want to tell you regarding the EIGRP protocol, in an EIGRP protocol, what happened? Take example. I'll put the router number 1, router 2, router 3, router 4, router 5, router 6, router 7, router 8. So all these routers are present in the autonomous system number 1, right? It means that on all the router, you will have an equal load. On all the router, you will have an equal load. What I can do that? In the case of OSPF protocol, we do have a concept of area. We do have a concept of area we can call as a domain. So with the help of OSPF, what I can do that, I can segregate this guy. I can say, okay, I'll make this guy as a part of the one area. These two guys are a part of the one area. And these three guys are a part of the another area. I'll make this guy the area number 1. I'll make this guy the area number 0. I'll make this guy the area number 2. So now what happened? I have segregated the load over there from the router perspective. So previously what happened? Every router was maintaining the equal load, right? Now I have segregated the same example is very simple. Take example, if I'm going to tell you, you have to manage the 12 students, right? So if I'm going to say that, hey, you have to manage the 12 students, it's very hard to manage the 12 student, right? But what I can do that, if I'm going to segregate this guy, I said, okay, let me segregate this guy. 4 student, 4 student, 4 student, 4 student. In that case, what happened? For one trainer, 4 student, one trainer, 4 student, one trainer, 4 student, one trainer, 4 student. What benefit you will get that? The load will be decreased on the trainer side and the performance will be increased. Now all this individual trainer will focus more part on the student side, right? Same thing is happening in the OSPF protocol. So performance-wise, OSPF is amazing. With the help of area, right, we can divide the big domain into the small domain, like a VLAN, right? So we'll put the area over there. So you can put the 80 area, that's not a big deal. But in 32-bit range of area, we have a total is 32-bit range, the area. So in this area, what happened? Area 0 is reserved area. Reserve means what? It is reserved by the engineers and RFCs as well. So this is called as the backbone area. Backbone area means what? It's like a, your body has a backbone, right? So if you don't have a backbone, right? If your backbone is not stable, you cannot walk even, right? Same thing. This area 0 must be present in your OSPF domain. If your area 0 is not there, then you cannot provide the inter-area communication. For example, we have router number 1 and we have router number 2. And then we have our router number 3 and router number 4 over there. So take example, this is the area number 1, this is the area number 2. You cannot provide the communication between this subnet to this guy to this guy. You cannot do that. R1 can, the user sitting behind the router number 1 and the user sitting behind the router number 4, they cannot communicate. The reason is that we don't have area 0. So you need to have area 0 to provide the communication. If you want to provide the inter-area communication, you need to do the area 0 over there at any cost. So right now, I'll just make sure that any area, that's fine. You will get to know that more area concept later. Area 0. Once I'm going to put this command, understand the concept now, right? Same thing, I'm going to put this command on the router number 2. On the router number 2, what happened? Those guys will be changed the router ID to 2.2.2.2.2. Immediately, this interface is now going to convert into the link now. Right? This interface is now going to convert into the link. This router is going to convert into the state, right? And if you want to establish the neighborship between this guy to this guy, we need to implement the rules over there, and that rule is called what? Protocol. That's why it's known as a link state routing protocol. Why we call as a link state routing protocol? Now this interface is called as a link, and the state is called as a router. And the protocol, you know the meaning of protocol. Before the OSPF, it was an interface. After enabling the OSPF on the particular interface, now it become the link over there. And now the router is behave like a state. Now, once this interface will enable in the OSPF protocol, now he's gonna share the information. What he's gonna share the information? He will share the link information. He will say the link information, and that link information is known as a LSA, link state advertisement. Focus the name. Link means what? State of the link, right? I'm going to say the state of the link. What is state of the link? This interface, right? So I'm going to share the information about the link to the router number 2. Router number 2 is going to share this link information to the router number 1. So when I'm going to share the link information, that's called as a LSA. So LSA will be categorized, right? LSA will be categorized based on the area. So depend on the area, you have a different types of LSA. So LSA is nothing but it's just a information about the link over there. LSA is nothing but just a information about the link. Depend on the LSA, they have a different meaning. But just for now, right? LSA is just a link information. Just for now. So once I'm gonna make this command line, I'll say that this router OSPF1 and the same way over there. Then what happened? This router is gonna send the OSPF hello packet, right? This guy also is gonna send the OSPF hello packet, and once the hello packet will be exchanged, they will form the OSPF neighborship. This hello packet will be sent on the 224.0.0.5 multicast address. So if you see, I'll just go to router number 1. Let me define I'll say the no router OSPF1. And I'll say the interface 0/0. Let me define the IP address 10.1.12.1/24, no shut. All done. And R2 now. Interface 0/0 10.1.12.2. And here we go. I'll make a loop backs over there. I'll treat this guy as a LAN network, right? And I have a loop back behind the router number 1 as well. I'll treat like a LAN network. So now the router number 1, I'll put the command router OSPF number 1. If you see, this is the 16-bit of number. You can define the any process ID. I'll use the 1 over there, and I'll router ID with the manually configuration. I'll always give the manual configuration of the router ID, and it is best way and always a recommendation to give the router IDs manually. And as the network is what? 12.0, right? And then I need to define the wildcard mask, which area they belong to the. So if you see, you need to say the area. So area you can define in the dotted decimal format, like IP address format, or you can simply define in the decimal format. It's a 32-bit range, right? So area 0 is reserved for the backbone area. And apart from, you have a normal area. So apart from the 0, all these guys are called as the normal areas. So I'll say the 0, right? That's a backbone area. You can use the 1 as well. If you have a single area, within the single area, right, you can put the routers over there, and you can use the any area, area 1 or maybe the 2, you can call it anything. But when the inter area comes in the picture, you must need to have a area 0. A normal waistband, simple as you can still say that. So on a router 1, I'm going to put the area 0, and on the router number 2, I'll say the router is 1, router ID will be 2.2.2.2, and 2.0, and area 0.0. So now if you see that, they will form the, they will extend the OSPF hello packet, and this hello packet will go on the multicast address .5. So if you want to capture this particular link, right, you will see that I have a OSPF hello packet from the router number 1, right? And if you see the packet, we have a Ethernet MAC address. The source MAC address of this interface CA0127, and destination is a multicast MAC address for the OSPF protocol 01005B. I already told you about this part, right? So the first 24 bits are reserved, and the remaining is this multicast address copied from the IP address, right? .5. This is the multicast MAC address for the OSPF protocol. Then we have our internet protocol version, IP network layer, we can call it. We have a protocol number 89. If you're going to open the OSPF packet, we have OSPF header over there. So if you see that the first header, we have a version, right? So by default, we are using the version 2 nowadays. We have a version 3 as well. Before the version 2, we have a version 1 as well. Some documents also say that there's a version 0 as well, but there is no documents available for the version 0. I read somewhere, but I don't see any version 0 is there nowadays. Version 1 was there, okay, and version 1 was a classful routing protocol only. So version 2 came in the pictures for the classless, but the version 2 only support for the IPv4. If you want to do the IPv6, you need to go with the version 3. So if you see the master stack, we have a hello packet. It could be changed. If you see this is the opcode value we have, the number over there. So it could be changed with the hello packet, right? Then you have a DVD packet. Then we have a link state update packet, LSU we can call it, link state request packet. Then we have a link state acknowledgement packet. So depending on the packet types, this will be changed over there. We'll see that each and every packet, don't worry. And the size of this packet is a 48 byte. The source OSPF router is a 1.1.1. The router 1 is setting this hello packet to router number 2. The area ID, you can see that's a 0.0.0. It's a backbone area. So I just define in the decimal, sorry, I just define in the decimal format. In the Wireshark, you will always see in the dotted decimal format. The checksum, that's just going to maintain the integrity of the OSPF hello packet. So layer 3 has its own checksum field, right? And OSPF has its own checksum. So OSPF is doing the integrity for the independently. They are not dependent on the IP header. And now we have authentication in null 0. So you have 3 types of authentication. Null is a 0 type of authentication. Text, that's called a clear text of authentication, that's a 1. And the MD5 we have is called the 2 over there. So right now there is no authentication, that's why we don't have any details over there. And now you can see the OSPF hello packet. So router dead interval is a 40-second, right? And the hello interval is 10-second. So I'll explain you these things later. No need to worry about that. But I understand this concept. This hello packet will send on this multicast address .5, right? And now also router 1 will send the hello packet. Router 2 also will send the hello packet. And if the neighborship criteria is matched, they will form the neighborship. So whatever the neighborship criteria they will match, right? So first you need to see the hello time, and hold on time must be seen. That's very, very important. It's a very important interview questions, guys. The criteria of the OSPF. So if the radar one is running with the hello is the 10 second, which is by default, and 40 second is the dead interval, and hello is a 10 second and dead is a 40 second over there. So yeah, that's fine. They will form the neighborship. But somehow if you're gonna configure this guy at 30 second, they won't form the neighborship. So it has to be matched. Network and subnet mask must be matched. It means that they must belong to the same network, right? Same subnet mask, this interface and this interface. Then we have a route ID must be different. Remember one thing, in the case of EIGRP, if you have a duplicate route ID, they still form the neighborship. So if you put the route ID on the router number one as a 1.1.1 and route two as a 1.1.1, EIGRP will form the neighborship. But in the case of OSPF, they will not. Route ID must be different. Then network type must be seen. I'll come into this part later, not worry. Somewhere this network type is like a, if it is not seen, still they will form the neighborship. Again, that is the higher level. They will not ask you this level, but yeah, at the level of the CCNA and NP, right? You need to give the answer. Guys, give me 1 minute. I'll just be back in. No, 1 minute. Just give me 1 minute. So the network type must be same. So see at the NANP label, right? This is very important to say that at the I label when you go, then this will be little varied, right? So, but yeah, you have to give this answer in the interview. Then we have a stuff and NSA flag must be seen, right? These things again comes in the later, in the last day of the, or not last day, maybe the Friday, you will see that this concept is stub and NSA part. And then hello, hold on, done. Network area should be seen. So if the RADA 1 is a part of this interface, is a part of the area 0, this should also be part of the area 0. Then they can form the neighborship. If you're gonna make this guy the area number 1, they won't form the neighborship. So these are the neighborship criteria that we have. It's very, very important. Somewhere you will see that MTU is also part of the neighborship criteria, but it's not a part of the neighborship criteria. It's a part of the adjacency criteria. Right? So even if your MTU is different, they will form the neighborship. So before forming the neighborship, right, data one and data two, before forming the neighborship, they has to both match everything. If something is not matched, they won't form the neighborship. So if you see right now, by default, everything is matching. That's why they form the neighborship. Right? If I'm going to change this guy, take example as the route ID will be 10101. They won't form the neighborship. I change the route ID. So my neighbor goes down and they will giving the message, hey, there's a duplicate route ID detected we have. So make sure that route ID should be unique. Otherwise, they won't form the neighborship. Now it's neighborship came up. So the reason why they are detecting for the route ID, because in the hello packet, we are seeing the route ID. You see? From where? Here. But in the case of EIGRP protocol, we don't see the router ID in a hello packet. That's why EIGRP doesn't have any issue. Yeah, so if you have a different router ID, they can form the name issue. Now, I think so all good, right? The basic part is clear. How you can enable the OSPF. So guys, anybody has a question now, you can, sorry, I haven't give you the chance to ask the question. If anybody has a question regarding the configuration perspective, you can ask me, right? If you have any concept. So let's make this guy the process ID to. Let me show you this thing as well. I'll remove this guy, no router OSPF 1. And also the router OSPF number 2 right now. And also the network 10.12.0, right? Area 0. They will form the name issue. We don't have an issue. So if the process ID is different, there's no panga. They can form the name issue.
So, process ID and the neighborship ID, they are same, right?
What is the neighborship ID? What is the neighborship
I
ID?
mean, neighborship ID means that if the router one has a, for instance, ID is 1.1.1.1, and the router
That's
two
called
dots,
as an router ID.
that is exactly that is the router ID, absolutely. And the router two has a, let's say, dot two, 2.2.2.2,
Doesn't
right?
matter. Router ID must be unique. Router ID
It
must
has
be
to be.
unique. Process ID can be different. That's fine.
So, what is the process ID, please? I mean,
Process ID is a number,
mhm,
integer number. It's a locally
right.
significant, right? And so locally significant is what? If you're gonna put the router number 1 as a process ID 1, and if you're gonna put the router ID process ID 2 over there, they want for they
Mhm,
will still form the navigation. They
right.
will just identify the route in the domain. So if you make a one process ID, they will get the one domain for this guy. So all the router belong to the one domain. It's like a same like autonomous system that we have seen that. Each process
So,
ID, each process ID has a separate router ID. Each process ID have a separate database table that OSPF is making, like a topology table. OSPF has a database table. Each process ID has a separate database table, and each process ID has a separate SPF algorithm as well. So understand one concept. So if the router 1 is running with the multiple process ID, OSPF number 1, OSPF number 2, OSPF number 3, then what happened? How many router ID you require? You require the 3 router ID over there. You require the 3 database table over there, and you require the 3 SPF algorithm over there.
so basically, process ID means there are multiple routers in a single domain, right?
Yeah, there are
And
multiple router in the single domain. It's like a domain, like
uh,
autonomous, same like autonomous system number.
exactly same like that, like AS, right? Okay.
Yeah, same like we did in the AJRP discuss.
Okay. So in one single domain, so let's say on this single domain there are three routers. So they all have a same. It has to be same process ID. Is
Right.
that right?
It's a recommendation to have a same one. You can put the different one as well because the good thing about that side is a locally significant, but AS number is not a locally significant. That's a major difference in that only.
But where do you actually configure the process ID? I mean,
I just
once you
configured
have
it. Yeah, see, this is the process ID.
okay, that is a process ID.
I think so.
Sorry. Okay.
You let join, right?
Yeah, just a little
Yeah,
bit. Yeah.
yeah, that's great.
Sorry.
Always be on the time because I am on the time always. Anyone else has
Okay.
any question, guys, regarding the configuration perspective? No? Okay. So now
So
understand.
process ID.
Yeah.
Sorry, last thing. Apologies. So the process ID. Uh, the process ID should be same if it's a single autonomous system,
Mhm.
and the router ID that could that
Must be different, must be unique,
must be to identify the.
right?
Right, that's fine. Thank you so much.
So guys, pay attention right now. So this is the switch we have. and this guy is going to connect with this like particular switch. This guy. All the router has a unique router ID. This guy, the router ID will be 2.2.2. This guy, the router ID 3.3.3. This guy, the router ID 4.4.4. This guy, the router ID 5.5.5. This guy, router ID 6.6.6. This is the interface we have, 0/0. The IP address of this interface, I'll call this as a 101. The interface we have, it's 102. The interface we have on 3, 104. One of 5. One of 6. Right. So you can see that in this broadcast domain, what happened? What I told you that if you remember that the difference between the EIGRP and OSPF, when you're gonna enable the OSPF, right? So they will elect the one router as a DR, another router as a BDR, and the remaining router will be DR and DR, right? So normally, remember this state is very important. DRO equal to the DRO, right? It's gonna form the neighborship only, right? DR with a DRO, it's gonna form the neighborship plus adjacency. BDR with DRO, it's also gonna form the neighborship adjacency, right? And then DR is equal to BDR. It's only gonna form the neighborship adjacency over there. Only if you see the DRO, only gonna form the neighborship. Neighborship means what? What I explained in that. Neighborship means they just know about the routers. There is a router number 2, there is a router number 3. They cannot exchange the update. So normally what happened in that case, understand the concept. When I'm gonna enable the OSPF protocol, take example, I have enabled the OSPF protocol on this particular interface, right? At 2 seconds, in a 2 second I have enabled it. Then I took the 10 second to enable this interface as OSPF. Then after the 20 second, I have took the time to enable this guy. Because of course you take some time, right, to enable those on each router. It took the 30 second, and this router will took the 40 second. And when I comes to this guy, it took the 42 second. So understand the concept, right? What happened? So the election time for DR and BDR is a 40 second, which is known as wait time. Guys, it's very, very important topic. Rarely you will find in the book, which is known as a wait time. You cannot change the wait time, but you can change the dead. But if you change the dead time, which call as a hold on time as well, right? Then wait will be changed. So if you're gonna make the dead interval is 100 second, the wait will be go with the 100 second. Now understand the concept. What happened? Within this time, right? Whatever the router has configured, within this 40-second, the DR and media timer, which is known as the wait time, within the 40-second, whatever the router is configured, only those routers will participate in the DR and media. Now you guys tell me, which router will participate in the DR media? Can R6 will participate in the DR media?
No.
No, he will not participate because only the till R5 comes in the 40-second, it will participate in the DR media. So it's simple logic, right? In a country, every country has election, right? The prime minister election, the president election. Once the election has done, after the election, right? After the result has passed, right? Nobody can come and say that, hey, you know one thing, I have a better knowledge than you, right? Nobody can come, right? Same thing. Once the election has done, still if you're gonna enable the OSPF on this particular interface, this guy will go with the DRO. This guy will go with the DRO, simply, right? So take example, what's the election criteria for this guy, DR media? So the election criteria for the DR media is what? Highest priority, which is by default 1, right? You can go up to 0 to 255. It's a 8-bit number. Default is what? 1. If the priority gets high, then it will go with the highest RID. This is the election criteria of the DRB. This is the default time, default priority. So the default priority, if you see on each interface will be 1. The default priority will be 1. The default priority will be 1. 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 So if the priority get tie, then what happened? Who has a higher route ID? Of course, the R6 has come in the 40-second, 42-second. He will never participate in the DR BDR. So the DR will become the route of 5. The BDR will become this guy. And the DRO will go with the this guy and this guy and this guy. Anyone has a question? Guys, it's a very important topic for the interview perspective. Very, very important one. And if you're planning for the CCN and CCNP exam, definitely you will get the 5 to 10% from here only. Anyone has a doubt in this one? How do I elect this guy? All clear?
Yes.
Now, let's take example. Let's say example. The priority is still 1, priority is still 1, priority is still 1, priority is still 1, priority is still 1. And now I have configured all this router within the 40-second. Now who will become the DR?
6.
6 will DR and he will go with the BDR, right? He will go with the DRO and he will go with the DRO and he will go with the DRO and he will also go with the DRO. Now, take example. If the DR goes down, then if the DR goes down, then what happened? The backup DR will become the DR. And now, between all this guy, right, the election will happen. And now the election will happen for what? BDR. So if your DR goes down, the backup DR will become the DR. And the between the DRO, the election will happen for the BDR only, not the DR. So who will be the higher route ID? Of course, the priority get tied. Who will be the higher route will become the BDR. So now this guy will become the BDR. After some time, if the DR comes in the picture, right? After some time, this router 6 come back, right? Then what happened? This guy will go with the DRO. Got it? Now, take example. What happened? Right now we have a DR, we have a BDR, and any other router is coming, router 8 is coming, and they are coming with this interface we have. This interface has a configure with the priority is what? Maybe 255 priority is configured, higher priority. So if this router 8 is trying to say, hey, do you know one thing? This is the hello packet, and in this hello packet, you're gonna send the priority information. If you see that, router priority is 1. So now in the hello packet, he said that, hey, my priority is a 255. I like to become the DR. He cannot participate in the DRBT election because it doesn't matter if you're coming after the election and if you have a higher knowledge, you cannot become a president, right? Same thing. If the priority is higher for this interface, he cannot participate in the DRBT election. He will go with the DR only. If the election is already happened, because already we have a DR, so you cannot become the DR. So if you want to become the DR, then what happened? You need to reinitiate the OSPF process again. You need to reinitiate the OSPF process again. You need to clear IP OSPF process. You need to restart the process. Then again, the election will happen and then you will become the DR over there. So this DR is like a preemptive behavior. Preemptive means what? If the process will restart, the higher priority can tell this person, hey, you know one thing, my priority is higher. I like to become the DR. So preemptive behavior.
Okay, so once the DR and BDR is elected, it won't change unless one of those goes down. And
Unless
yeah,
goes down,
you have
or
to
unless
reinitiate.
the process will not restart.
Okay, okay, thank you.
Right. So
But please, how do you um, how do you initiate the process
how do
again?
we initiate the restart of process? I'll show you that, don't worry. There's a
Okay.
command for that one. So command is very simple. I just need to go on the router and say that clear IP OSPF process.
Okay.
Either you can put the command manually. So if you put the enter over there, they will ask you, are you sure? Just put the yes. Yes, I'm sure. The process will restart. So you need to restart the process on every router. Or either you can re-enable the configuration, remove the configuration and re-enable it. Or shut and no shutdown interface. So you can also do that. So anyways, doing all these things, right, you are eventually restarting the OSPF process. So now have a look over there. And what I told you that if you remember that, so take example, what I told you that. So all the DRO route, if you see, all the DRO is going to form the neighborship. So DRO only neighborship we have, DRO only neighborship we have, DRO only neighborship we have, right? DRO only neighborship we have, DRO only neighborship we have, and DRO only neighborship we have. But all the DRO is going to form the neighborship then adjacency with the DR. So this DR is going to form the neighborship adjacency with the DR. Same way this guy. Same way this guy. With this person as well, BDR as well. Right? So this chart is very important. Have a look. Let me. Yeah. Right.
DR means the DR others, right?
Yeah, DR others. So we have I forget to mention that. Designated
That's
route.
okay. No, that's absolutely fine. No problem. Okay, so if we say the highest priority, right?
Mhm.
Excuse me. Any doctor has the highest priority, that will become the DR, then the
The priority
second
gets
highest
high.
priority,
By default, priority is 1, right? If the priority gets high, then highest route ID comes in the picture.
highest router
Okay.
ID means that will be 0 to 0-255, right? The
Route ID,
maximum numbers.
route ID, route ID, route ID.
Okay, sorry, yeah. You can.
Remember, that's why I told you that.
Yeah, I know you just told me. Please, can
But
you please try using other colors?
sorry,
This is too light.
sorry.
I mean, the color using that is very light. I mean,
Okay,
the
this one. Okay, this one. Okay, I'll change this.
thank you so much. Yeah.
Remember only one thing, right? Many person has a confusion over this part. If you have a DR, then backup DR, why the backup DR comes in the picture? Backup DR only you have just to provide the faster convergence. If the DR goes down, immediately backup DR will become the DR and the LXM will happen for the BDR. And one more thing, for each broadcast domain, you have a separate DR bit. So DR BDR is only for the one broadcast domain. So if you have a two broadcast domain, you have a two DR. If you have three broadcast domain, you have a three DR BDR. So DR BDR is per broadcast domain, right? DR BDR is a per broadcast domain behavior. So take example, if you have multiple DR BDR, sorry, multiple broadcast domain, take example. We have router number one. You have a, okay, let me show you in the lab. Wait a 1 minute. Let me see which lab I have. No. Oh, I must have. What's putting it? I know it's a bulky, but understand. So they all are part of the single area, right? There's no other area. So we have a single area right now. I'll make sure this guy's a big size. So they all are a part of the single area 0, right? Every data. So, but if you see one thing, let me start all this guy. If you see one thing, these all are the part of the one broadcast domain, right? Let me do one thing. Let me highlight this thing. Right? They are the part of the one broadcast domain. Go on here and I'll go with a different color. That is fine. Perfect. Well, not bad. This one. Perfect. And then I'll take a, so one broadcast domain over here we have, if you see that. Right, lower one layer. And one broadcast domain here we have. Perfect, right? They all part of the same area right now. So let me turn on my all devices. So DR, BDR information are present in the hello packet. So in the hello packet, you will see the DR and BDR. So if you see the any hello packet right now, I'm so sorry. And if you go now, so you can see that DR is a 12.1 and backup DR is a 12.2. So DR, BDR information are present in the hello packet. So few things I need to write. higher priority, higher RYD. Make a notes something from the paint file as well, because I cannot write everything in the notepad. Okay. So now we have router 1, which I'm missing, router 2, router 3, router 2 is missing. 1, 2, 3, 4, 5, 6, 7. How many we have? 8 over there. So which one is in router 2 is missing? All done. So I hope the IP is pre-configured. If you understand this topology right, then you will never stuck in the DR and BDLX. Never ever. So IP interface brief. You can see router number 1, we have router 1, we have a router 1, and we have a look back over there. I'm going to consider this is the router ID. Same way, you can go on the router number 2 right now. So IP interface brief. You can see on the router number 2, we have 1.2 right now, and 2.2. That's this guy. Router 3, if you go, router 3 has a 1.3 right now, and 3.3 has a look back. And router 4, if you go to, same way 1.4 and 4.4, we have a look back over here. Router 5 now. And here we go with the, if it's router 5, I have 2 interface map, 2 physical interface I'm talking about. So one we have 57.7 this side, and 55, 1.5 on this side, and then look back over there. And router 6 now, and router 6 also will have a one interface as a physical interface 0/0 1.6 and look back 6.6. Router 7, if you see, all done, 78.7 and 7.7. So this interface is the 57.7 and this interface is the 78, or let me write on this thing. 57.5. 57.7. Here we go. This guy will be 78.7. 78.8. Meantime, let me write down something. In OSPF, we have 4 different type of network. So we can call it OSPF is a smart protocol than EIGRP. In EIGRP, what happened? Right? Take example. We have router 1 to the router 2. So this is the fast Ethernet 0/0 link, and this is a fast 0/0 link. So OSPF just consider this network is a network. If you have a serial link as well, right? So sorry, EIGRP just consider this is a network. In a EIGRP also gonna configure this serial link if we have, then also EIGRP is gonna configure as a normal network. So EIGRP doesn't have this intelligence that based on the link, he can consider this is a different types of network. Well, EIGRP doesn't have. EIGRP, any like link connectivity you have between the routers, they just consider this is just a topology we have for me, normal topology. But in OSPF, what happened? OSPF has an intelligence. OSPF, each network, or we can say each interface, they behave like a different types of network. So on all the Ethernet technology, right, you will see as a broadcast network type. On all Ethernet. So right now you can see that this is the fast Ethernet 0/0, right? So all bill comes in the broadcast network. And in the broadcast network, you have a DR and VDR. Then if you have serial link, right, that's comes in the point-to-point by default. On the point-to-point network, you don't have a BDR, no DR and BDR. You don't have this thing. Then you have a point to multi-point, right? Again, the point to multi-point, you don't have a DR and BDR. non-broadcast, another one we have, and BMA network we can call it. We have a DRM media. Right? So OSPF has an intelligence, they can identify either this is the cellular link or the Ethernet link, right? So the default, if you see, it go with the broadcast network, right? On all the Ethernet technology. So when you're gonna enable the OSPF protocol, right? So in the broadcast network, you have a DRM media. So this kind of intelligence doesn't happen in the EIGRP protocol. So let's enable the OSPF, right? So what I can do that, configure this guy, .OSPF number 1. Let me do one thing. I'll better to put this command on the notepad so that I can copy and paste it. Okay. I need to configure all this guy in the 40 seconds. So for this particular subnet, right, I'm going to configure in the 40 second. So router 1. Victim and router 3 we have. Router 4 we have. Router 5 we have. And router 6 we have. There's a 6. So this network I have configured in the 40 second. Right? So now if you see the do show IP OSPF interface, have a look what you can figure out. So there's a wait time is going on 40 seconds, right? So the election is going right now. So within the election, there is no DR NVIDIA. So in the hello packet, during the election, if you're going to extend the hello packet, you will see the DR is a and BDR is a. So it means that what? The DR and BDR has not been elected yet. So there's no DR and BDR. Wait for some time. You will see that. I'll show you some OSPF in the initial OSPF hello packet. There will be no DR BDR. Can you see that? It's not there, meaning that election is going right now, right? Wait some time, you will see that. So now you can see that my neighborship has formed. So what do you think? Who will become the neighborship? Or who will become the DR in this red color? Yeah, not a red, what we call, I don't know which color. So what we call? So who will be the DR in this picture? The priority is by default 1 by default, right? The priority, if you see, by default is 1 on all interfaces.
6.
6 will become the DR, and who will be the backup DR?
5.
5, and all this guy will go with the DR, right? So if you check on the router number 6 right now, or maybe router number 1, what you can figure out. So IP OSPF interface brief, my state is a DRO. So this interface is named in the OSPF reserve, process ID is 1, the area is a 0. This is the IP address and mask information. The cost of this particular link, that's called the matrix, is 1. And the state is a DRO.
But please, why is it that DROTH? What's the TH?
DR other.
Okay.
DR other. That's
Okay.
a DR.
Okay. All right.
DR and OTHR others.
Okay.
So
Alright.
DRO is only gonna form the neighborship and adjacency with the DR and BDR, right? So if you see the adjacency, you will only have a 2, right? So IP OSPF interface. You can see that I just have adjacent count with 5 and 6 with the backup DR and DR. But I will have a neighbor with every person, right? So you can see the neighbor count is what? 5. But adjacency with the DR and BDR. But I will have a neighborship with everybody. Same thing if you go on the router 6 right now. My state is a DR. And who is the BDR? You can also see that from here only. So you can see router 6 is a DR. So router 6 is gonna form the neighborship adjacency with every person. And backup DR is a R6 is saying this information, right? You can also see from here as well. And what is the network type we have by default? Broadcast on the Ethernet segment. And if you have a broadcast network, then you have a DR and VDR. Right? Let's enable the OSPF over there. See if I'm going to enable the OSPF between the R5 to R7. How can I do that? I'll say router OSPF number 1. Network. I'm going to enable the 57.0. Right? Area 0. Same thing on the router 7 now. With this command. So if you see the do show IP OSPF interface brief, the waiting state is going on right now. I have to wait for the 40 seconds. Till the 40 seconds, there will be no DR, BDR in this domain, in this broadcast domain. Priority is by default 1, state is waiting. So there will be no DR, BDR. Right now, after the 40 seconds, who will become the DR, BDR? Can anyone tell me?
The 7.
57.7, right? Because this guy is hired already. Priority get tied, then this guy will become the DR. So if you see, do so IP OSPF interface brief again. And the R5 will become the BDR. So there will be no DRO over there. If you go on the router 5, you can see this interface 1/0, it's a BDR. At the same time, this interface is also BDR. So DR and BDR is the properties of the interface, not the router.
Okay.
Okay, it's not a properties of the router, it's a properties of the interface. So one router, right? Take examples for router number 1. That's a part of the router 3 connected, router 4 connected, and router 5 connected, and router 6 connected. So this router 1 can become the DR for all the broadcast domain. I'll make sure that the priority, I'll make this guy priorities are 255 on all interfaces. So if I'm going to configure the 255 priority on all interfaces, then what happened? You will be the DR, right? For all the domain. So DR is the properties of the interface, not the router. Many person has the confusion over this thing. All the percentages, I'm telling you, the 80% people, right, who has a fresher in the market right now, always that, okay, the DR, this is the router is a DR. A router cannot become a DR. Interface always a DR.
Okay.
Right? So you can see that on the router 5, I'll make this guy 1/0. I'll increase the priority for this guy. If you see that interface 1/0, I'll say the IP OSPF priority. I'll make this guy the 255 higher priority. So right now he cannot become the DR. I'll say the clear IP OSPF process. Let me restart the process. Yes, and on router 7 as well. Wait for some time. So I have increased the priority. So now this guy will become the DR, right? Because the higher priority they have. So now you can see the show IP OSPF interface brief. You can see that this interface has become the DR. And this interface go in the DRO. The reason is that I just initiate the restart process. So the BDR has failed. So another router will become the DR for this guy. So BDR has failed on this particular interface. And this guy will the DRO. So you can see that this interface is now DR and this interface is BDR. So what do you understand? One interface can be a DRO, another interface can be a DR.
Okay.
Right?
Okay, but okay,
Yeah.
but sir, please. Okay, so in this case, can you have the same router with two different interfaces, being the DR and at the same time the BDR?
Yeah,
One
we
router.
can do that. We can do that. We can. So what we can do that in that case, I'll tell you. So you just need to increase the priority of this guy's at 255. This guy will make it this guy's at 254, right? And all these guys are 0 priority. So the priority 0 is a special priority. So priority 0 cannot become a DR and BDR. They always go with the DR. And
Okay.
this guy will make this guy 255. So in that case, what this interface will be going to DRO because it has a lower priority than the DR. And this guy will go with the DR.
Okay.
Got it?
Alright.
Priority 0 is special priority. If you configure the interface as a priority 0, that will always go with the DRO. So let me take example. I'll go on the router number 7 right now. And on the router 7, I'll say the interface 0/0 IPOs or not 0/0 interface 1/0. IPOs for priority will be what? Then now show IPOs for interface brief. You always go with the DRO. The
Okay.
reason is that I have a priority 0 configured. The priority 0 means what? So in this domain, what happened? We have a DR.
Okay.
We don't have a BDR. We just have a DRO.
Okay.
So when you set the priority 0, so how about the other interface, which is in a F0/0 in
This is the different broadcast domain, right? So in a one broadcast domain, you have only one DR and BDR. So when I'm going to configure this guy, so I have changed the priority for interface basis, not the router basis. So this guy has a default priority is 1 still.
So that means there will be no change on that side, right?
There is no changes of that side.
Okay, so coming back to the router number 5,
Mhm.
so you have one DR and one DR other, right? So the F0/0, you have a set up the priority 255, isn't it?
Yeah.
And the other side you have set up the priority 251, is it?
No, I haven't shared. It's I just explained the knee has asked question. That's why I explained that.
Okay, but how, I mean, I was gonna ask you, but obviously didn't want to disturb you. So on this specific router 5, so DR is become and a DR other is because of the high priority or high router ID or
This DR has become because of the higher priority.
okay, so what is the priority on the other side then?
That is understood 1 right now.
Sorry?
1 by default 1.
Okay, so basically, okay, so the election process come up, and because of the higher priority, it will that will be elected as a DR because of the higher priority.
Right.
Okay, so priority is 0-255.
I have set it over there, right, manually.
No, I mean that is fine, but I'm just saying that by default is 0-255, right? It can be
By
anyone.
default, it's 1.
Okay, but
The default
No,
priority.
no, okay, no, okay, sir. Okay, sir. From what he's saying, he was asking that is it between 0 to 255? If you can select it,
No,
are you
I
able to
understand.
select?
I understand the Nasir question. So Nasir is asking, Nasir is confused about the key. Nasir is thinking like a 0 to 255 is the priority. This is the range of the priority, Nasir.
yeah,
Is-
that's exactly what I was saying.
Yeah, that's a range.
So
That's a range. The priority in this range, you will only have one value in you. So this one is a default priority.
so, but you can choose any number from
Yeah,
0
you
to
can
50,
choose any number.
Yes.
but
Okay.
default is number 1.
Higher number is always preferred.
Okay.
Range is 0 to 255, and by default is 1, but it has to be onwards from 1, right? It can't
Yeah,
be
it's
0, isn't
always
it?
onwards for onwards. But you can, if you set the 0, they will never participate in the DRM media. So on a router 7, if you see, I set the 0.
Right.
So it will
Oh.
always go with the DRO.
Okay, 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 okay.
Now,
Okay,
one
so
more thing. Yeah, go ahead.
okay, so let's say we have about 5 different routers. Okay, then maybe router 1, I can set maybe we can set the priority to like 4. Then we can set the second one to 3. Then the other one 0, 0, 0. So that means 4 will become the DR, and the router 2 become the um, BDR. Then the rest will be
So if no, that's not a good way to configure it, Neil. So if you want to make certain data as a certain interface is a DR, better to configure the higher priority 255. And if you want to make the another router should be with BDR, the configure the another router is a 254 priority.
Okay.
That's always go with the higher range. Don't go with the lower range. So if you're gonna use the 2 and 3, something like that value, then what happened? Take example, another router comes in the picture, and they have a higher priority, so they will print the other guy, right? If the process will be restart.
Okay. Thank you very much. Thank you.
Now, if you see one thing, what I told you that over there in the point-to-point network, we don't have a DRM media concept, right? So you can change the network type. Default is a broadcast network type, right? On the Ethernet technology. So on the router 7, if you see on this particular interface, what I can do that I'm going to enable the OSPF, right? Router OSPF number 1, and I said the network 78.0, area 0, and same thing on the router 8 as well. Area 0, and hit enter, and R7 hit enter. Interface 0/0. I say the IP OSPF network type is point to point, and R8 as well. On this particular interface, IP OSPF network type point to point. So if I'm going to change the network type from broadcast to the point to point, then what happened? You don't have a DR and VDR over there. You will have a neighborship, but you don't have a DR and VDR. So if you see so IP OSPF neighbor, I do have a neighborship, right? But I don't have a DR and VDR. So if you change the network type as a point to point, you don't have any DR and VDR over there. Understood?
Yes, sir.
So even if I'm going to configure this interface as a priority 0, so right now DRO I have configured this R7 I have configured the priority 0. So even if you configure the R7, if you see that, so both the interface, this guy is a priority 0 right now. So this is also like a DRO, and this is like a point to point. So everything, right? You have a properties of the interface. DR is the properties of interface. DRO is the properties of interface. BDR is the properties of interface, right? So it's all depend on the how you manipulate this thing. All good?
I think that's enough for today.
Yeah, DR BDR information exchange the hello packet. So yeah, that's enough for today. So I'm gonna not take so much time. We'll do the DR BDR things tomorrow as well. I have a few things more. So we'll do the DR BDR tomorrow as well. Then after that, we'll go in the further things. Then the LSA comes in the picture. Thanks very much. Yeah, thanks.
All right, welcome back.
Thank you.
Thank you. So I haven't put all the information in the notepad, guys. So better to copy the information from the paint as well. So for this guy was we have CC name. Thanks, class. All right. So I just gave you the overview of the DRM media. So we'll do the little bit more stuff tomorrow as well, and then we'll jump to the next topic. Okay.
Okay,
Sure.
sir.
Bye bye.
Thank you.
Thank you.